Okay. So this question we have to work out today. Remaining 4 questions we solved yesterday. Could you please read the question carefully? In an experiment, 400 grams of aluminum with a specific capacity of 900 joules per kilogram Kelvin at 100 degrees Celsius is mixed with 50 grams of water at 20 degrees Celsius with a mixture thermally isolated. That means you take 2 components. What are they? Aluminium and water. What is the mass of the aluminium? What is the mass of the aluminium?
400.
Mass of the aluminium is given as 400 gram. So you have to convert it to kilogram. Am I right?
Yes.
And then
0.4.
what is the specific heat capacity of the aluminium? It's a constant which is given 900. Am I right? Joules per kilogram Kelvin. And then the initial temperature of the aluminium is given. So Ti initial of aluminium is 100 degrees Celsius. I will convert this in terms of Kelvin. So what you have to do? You have to add 273 here. So then it becomes
373.
373 Kelvin. Okay. Likewise, you mix the same thing with water. So what is the mass of the water? Mass of the water 50 grams. So 50 multiplied by 10 to the power of minus 3. And the initial temperature of the water is given. Am I right?
Yes.
20 degrees Celsius. If you add 273 here, you will get 293 Kelvin. And also, my dear, you need the specific heat capacity of the water because this is a constant value. And that value, the specific heat capacity of the water is 4190 joules per kilogram Kelvin. It will be given. So don't worry. Clear? So what you are taking in this question, you take this and you are mixing this aluminium with water. When you mix, what will happen, my dear? Just think, the initial temperature of the aluminium is 100 degrees Celsius, but the initial temperature of the water is 20 degrees Celsius. When you mix these together, what will happen?
will be
Equilibrium.
Equilibrium temperature will maintain. Am I right? And that temperature is common for both. Am I right?
Yes.
When you mix the hot with the cold, what will happen? After sometimes the water becomes the same temperature. So here you take the aluminum temperature as 100 degrees Celsius, but the water temperature, initial temperature is 20 degrees Celsius. When you mix these together, what will happen? After some time, the equilibrium temperature will be maintained, and that is the final temperature of aluminum as well as water. Am I right? Am I right or not?
Yes.
Okay. Now we have to write the equation, the most important equation. What happened when you mixed this with water? Which one will gain the heat? Which one will lose the heat?
the aluminium will lose.
Okay.
The water will gain.
Very good. So because when you just mix this 100 degree with 20, water is gaining the heat and aluminum is going to lose the heat. So I can just write heat gain by water plus heat lost by aluminium, which is equal to 0. Am I right? This is a general equation. Am I right or not?
Yes. Yes.
When you move this to the right hand side, what will happen? This positive becomes negative. Am I right? So
Yes.
Here heat gained by water, which is equal to negative of heat lost by aluminium. Am I right?
Yes.
Okay. What is the formula for heat? What is the formula for heat transfer? We know mc delta T. Am I right?
Yes.
So I can use this equation for both the left hand side and right hand side. So here if you write, what you'll get, this becomes mass of the water, specific heat capacity of the water, and delta T. What is delta T? T final of water minus T initial of water. Am I right?
Yes.
Likewise, right hand side, negative. Again, I have to write the same formula. Mass of the aluminium, specific heat capacity of the aluminium, and then final temperature of aluminium minus initial temperature of aluminium. Am I right?
Yes.
Now you have all the values except these. Am I right? Am I right?
Yes.
And this final temperature is both common for aluminium and water. Am I right?
Yes.
So I can write here, instead of writing this, I can just write T final. Clear? Because this T final is common for both aluminium and water. Am I right? Am I right or not?
Yes, Doctor. Yes.
Okay, now substitute the value. You have all the values. What are the things? Mass of the water, 50 grams. So 50 multiplied by 10 to the power of minus 3. Specific heat capacity, 4190. Multiplied by T final, we are going to find. What is the T initial? What is the T initial? 293.
293.
Which is because we have to convert to Kelvin, you know, minus mass of the aluminium. Mass of the aluminium, 400 grams. So 400 multiplied by 10 to the power of minus 3. Specific heat capacity 900. And the T final we are going to find. And what is the T initial? 373. Now, my dear, it's a very easiest thing. Please solve the question. Just separate the T F one side and bring the values to the left hand side. When you just rearrange this equation, you can easily find the value of TF. Am I right?
Yes.
So for the time being, I can just write the value from the slide. I noted the value here. Yes, my dear.
I don't understand how you get the temperature final.
My dear, when you mixed this temperature with water, what will happen? After sometimes the water will maintain the same temperature. Am I right? Water and aluminum will get the same temperature. Am I right?
From what I'm asking, how did you take out the final temperature outside?
My dear, this is the basic mathematics, my dear. Okay,
yeah.
If you need, I can, because I don't want to waste the time. That's what, because this is for it's just the easiest calculation. Why I have to do these things? You have to do. Okay, so you can just see this. I can keep these things. First of all, what I am going to do, I can just multiply. So I can just keep this here. I can multiply this. Could you please multiply and tell me the answer? Could you please multiply and tell me the answer? (50) 10 to the power of minus 3 multiplied by 4190. I got 209. Am I right?
Yes.
Yeah.
0.5.
0.5 multiplied by TF minus 293. Am I right? And here, if we just multiply this, minus 400 10 to the power of minus 3 multiplied by 900. I got minus 360. Am I right?
Yes.
Yes, you're right.
Minus 360 here. TF minus 373. Could you please multiply this inside? If you multiply this inside, what you will get, my dear?
209.
If you multiply this inside, what you will get? 209.5 TF. And if you multiply this inside, what you will get? Minus of 209.5 multiplied by 293.
6328.
Okay, 61613.
No, no, doctor.
834.
603281. 1 minute.
How I got this answer?
Correct, Victor. Correct.
603281.
My dear, calculate properly. Calculate properly.
Yes.
209.5 multiplied by 293. I got this value. This is correct or not?
Yes, correct. Sorry.
Yes, that's correct.
Okay, now when you just multiply this inside, you will get a 360 TF, and minus into minus become plus. 360 minus 373,
134.
sorry, 360 multiplied by 373, I got
134
134280. Am I right?
280. Yes, you're right.
Okay, now move this value to the left hand side. When you move this, it becomes positive. Am I right?
Yes, you're right.
When you move this to the right hand side, this become positive right hand side. So I am going to separate TF one side. So 209.5 TF plus 360 TF, which is equal to 134280 plus 61383.5. Am I right? 209.5
Yes.
plus 360 gives me 569.5 TF. Am I right? Which is equal to 134280 plus 61383.5, 61383.5, which gives 19563.5. Am I right? Now, therefore, TF, which is equal to 19563.5 divided by 569.5. Am I right? Am I right or not?
Yes, yes,
Yes,
Victor. Please.
So I got the answer. I got the answer as 343.57. So I can just write 343.6 Kelvin. Am I right?
yes, Victor.
Yes.
Clear? Okay. Now we find the answer for the first question. What they given? What they given in the first question? What is the equilibrium temperature? So, my dear, listen carefully. The equilibrium temperature for both water as well as the aluminium is 343 Kelvin. Clear? Clear?
Clear, Doctor.
Yes.
Okay. What is given in the second question? What are the entropy change of the aluminium and what are the entropy changes for the water? So you have to find the delta S for water as well as aluminium. So what I am going to do, B question I am going to find. My dear, listen carefully. We know the formula for delta S. Am I right? So first I am going to find the aluminium. So change in entropy of the aluminium, we have the formula dq over T average. Am I right? Sorry, dq over T initial temperature and final temperature. Am I right? Am I right?
Yes, you are.
What
Yes,
is this
Victor.
dq? I can write mc, that means mass of the aluminium, specific capacity of the aluminium, multiplied by delta T. So delta T I can write dt here. Am I right? Am I right or not? Divided by
Yes, Victor. Yes.
T integration of what is the initial temperature of the aluminium? What is the initial temperature of the aluminium? The initial temperature of the aluminium is
373 maybe.
373. 370. What is the initial temperature, my dear?
It's given.
Yes, 373 Kelvin.
So initial temperature is 373. Here. And what is the final temperature?
343.6.
343.6. Am I right? Now I'm going to work out this integration. What are the constant term? I'm going to take the constant term outside because mass of the aluminium is the constant, specific heat capacity is constant. So I have only dt over T inside the integral. So my initial temperature is 373. My final temperature is 343.6. So my dear, integration of dt over T is nothing but natural log of T. Am I right?
Yes.
So what I am going to do, I'm going to substitute this value of natural log here. So mass of the aluminium, specific capacity of the aluminium, and natural log of T. So here my T value is given as 373. That means my lower limit is 373. My upper limit is 343.6. Am I right? Now You can substitute the value. If you substitute the value, what you will get, my dear? Mass of the aluminium, specific capacity of the aluminium, the natural log of, how you can write? 3 upper limit. What is that upper limit? 343.6 divided by 373. Now substitute the value here. Mass of the aluminium is given in the question as 400 gram. And the specific capacity of the aluminium is 900. A natural log of 343.6 divided by 373. When you work out this, you will get the answer of change in entropy of aluminium. Am I right? Am I right?
Yes, Dexter, yes.
In the similar way, you have to find the change in entropy of water. So you have to use the same thing. What you have to do? In this place, you have to substitute the initial temperature of the water, because the final temperature is common for both aluminium or water. So you have to repeat the same step here. Substitute the value. You will get the answer for the water. Am I right?
Yes, Dexter, yes.
And then let's we just go for the last question. What is given in the last question? Because 4 sub questions are given there. We already find the answer for the first question. What is the equilibrium temperature? And we find the entropy for the aluminium. We find the entropy of the water. And what is the last question?
The aluminum water system.
So you have to find the change in entropy of the total system. So how you can find, my dear? D, which is equal to, so change in entropy of the total system, which is equal to change in entropy of the aluminium plus change in entropy of the water. So you have this value, you have this value. When you substitute the value here, you will get the answer here. Am I right?
Yes.
Am I right? That's it. So this question is one of the important question. Please, my dear, take practice. Clear?
Dexter,
Yes.
can you go down, please? Little bit.
Yes, my dear.
Here. Why you divide 343.6
My dear, what is the logarithmic rule, my dear? Actually, you will get like this. Listen carefully. Actually, you will get like this. Natural log of T final minus T initial you will get. Am I right?
Yes.
If you use the logarithmic rule, you can write in the division form. This is the logarithmic rule.
Okay.
Clear? So in this place,
Yes, yes.
actually, when you are using this here, actually the first step will be this, but based on the logarithmic rule, you can write in the division form. Clear?
Yes, clear, Dexter. Thank you.
That's it. So my dear, chapter 20 is over. Now we have to start chapter 21. It's very easiest chapter. So please listen carefully. It's just a story. You already studied these things in your school life. I'm going to repeat the same thing again. So I think right now the time is exactly 2:20 and we have classes up to 2:50. Am I right? Am I right?
Yes, yes.
Okay,
Yes.
so I can just tell you, I'm going to tell you the story, what you studied in your school life. It's exactly the same. My dear, listen carefully. In chapter 21, you are going to study the concept of, charge. So, my dear, we already studied the concept of charges in the school life, about positive charge, negative charge, many things we studied. Am I right? So I am going to repeat the same thing now here. Actually, the title of the chapter is Coulomb's law. Coulomb is the name of the scientist, and he predicts the law by using the charges. That's what his name is given for that law. And in this chapter, you are going to study only 2 formulas, and all the 5 problems are based on these 2 only. It's very easiest chapter, and your midterm portion, for your midterm portion, this chapter is included. So totally 6 chapter week. Yes. Yes, my dear.
Complete, Doctor, complete. I'm sorry.
For your midterm portion, we consider 6 chapter. It start from chapter number 16 to 21. Understand? So this chapter is very easy. So please, my dear, if you have any question from this chapter, please don't miss this type of question. It will be very easy. Only 2 formulas in this chapter. It's very easy. Okay, I just move the slide. So if you just see the first slide, in this slide, we are going to study the concept of the structure of the atom. Everybody, we know the structure of the atoms, am I right? So you can just read, I gave 6 points here, and all these points, we already know this information in our school life. So just read the first point. What is given here? All objects are made up of atoms. Am I right? Do you agree with that?
Yes.
Yes.
Yes,
Okay,
yes,
very
Dr.
good. And second point, all atoms in the periodic table except hydrogen is made up of proton, neutron, and electron. Because the hydrogen has only the proton, so there will be no electron. So except hydrogen atoms, if you take the periodic table elements, all the atoms, all the elements which has the proton, neutrons, and electrons. Now, when you just see the third point, what is given the third point? The size of the atoms, just we compare the size of the atom with the nucleus, because inside the atoms you have the nucleus. Atoms itself, the size is very small. So what should be the size of the nucleus, my dear? It will be much more smaller than the atom. Am I right? You can see the picture. This is the structure of the atom, and inside the atoms you have the nucleus. So the atom size is 10 to the power of minus 8 centimeter. What should be the size of the nucleus? It will be smaller than atom. So that information is given here. Now, if you see the fourth point, the mass of the proton and the neutrons are approximately the same. You can see this mass of the proton is given here as 1.675, 10 to the power of minus 27 kilogram. And if you just see the proton is also have the same value. Am I right? Both are exactly closer to each other. Am I right or not? That information is given in this fourth point. Now, if you come for the fifth point, we just compare the size of the electron with proton. My dear, electron, when you compare the size of the electron with the proton, what should be the size of the electron, my dear? You can see here, the size of the electron is 1830 times smaller than the proton. So what is the mass of the electron? You can see, you can compare this value with proton. So our mass of the electron is this, and the mass of the proton is this. So if you just compare these two values, your size of the mass, that means the mass of the electron is 1830 times smaller than the protons. Now, if you come and see the charge value for both proton and the electron, both have the same value, but the sign matters. So the proton has the positive charge, but the electron has the negative charge. Clear? Clear, my dear?
Yes.
Yeah.
Okay. Now, in this slide, we already know, you already studied this information in chemistry. So we have two things. When you take any elements from the periodic table, the atomic number and mass number plays an important role. Am I right? So that information is given here. I gave an example of uranium isotope here from the periodic table, and here you have two numbers. A is nothing but the mass number and Z is the atomic number. My dear, if you take the uranium atom, 235 is the mass number and 92 is the atomic number. What is atomic number? Atomic number is the number of proton or electron. But mass number is the number of proton plus neutron. And these are all some basic information. We already studied this in our chemistry. Am I right? Am I right or not?
Yes.
Yes.
And these are some idea. That's it. We are not going to ask any question from this, but anyhow, you have to know when you study the concept of charge, these are all the information which is needed. So now in this slide, what you understand, we gave some classification of the material, and also we gave some information about the electric charge, because the main hero of this chapter is the charge. So what is charge? The electric charge is the fundamental property of the matter. If you take a matter, because we have solid, liquid, gas, many matters, am I right? We have three matters. So if you take the matter, electric charge is the fundamental property because it's composed of atoms. Because when you come for study the concept of this charge, atoms plays an important role. When electric charge, because electric charge is the natural property of the matter, due to which it experiences the force when you place near the another charge. For example, what is the meaning of the second line? My dear, listen carefully. What is the meaning for this? If you want, for example, I am going to take a positive charge, I am going to take a negative charge. My dear, when you place the positive charge near to another charge, what will happen? It will experience the force. Am I right? Now I have a positive charge, I have the negative charge. When I place positive charge closer to the negative charge, what will happen?
Well,
They will join.
It will attract each other. Suppose if you take positive charge and positive charge, what will happen? If you take negative charge and negative charge, what will happen? Both cases, it will repel. Am I right?
Yes.
Yes.
Because like charges repel, unlike charges attract. So these information, so how a charge will knows the other charge, the charge will knows the other charge with the help of the electric field lines. Inshallah, you will study the concept of electrical field lines in next chapter, electric field, because chapter number 22 tells you about the electric field. So by the time you will get the clear information about the electric field lines. But generally, if you take one charge, if you put the charge to the neighboring charge, based on the force, it will observe what type of charge is there. And the unit for the charge is Coulomb, because Coulomb, he used these things. That's what his name is given for the unit as a Coulomb. Now, if you classify the material based on the free electron, have you ever heard this word free electron? Have you ever heard the word free electron?
Yes,
Yeah, electrons.
we can lose it.
What is free electrons? Now my question, what is free electron?
Quickly.
Huh?
We can lose the electron.
If you take any element in the outermost orbit, it has only one free electron. That means lone electron, and that lone electron is called, that means it is not pair, it is single. So that single electron is called as free electrons or valence electron. Now, if you want to classify the material based on the free electrons, we can classify the material into four different types. What are they? We can classify in terms of conductors, insulators, semiconductors, and superconductors. So what are the conductors? If you take the periodic colors table, if you take all the elements, all the metals from the periodic table, all metals comes under the category of conductors. So it has the good conducting nature. We studied the thermodynamics, heat transfer from hot region to cold region, and we studied the formula for the conduction rate. If you take any material, if you put that material in the heat will be easily moves in the conductor. We already studied these things in the chapter 18. Am I right? Am I right?
Yes, lecture.
Why the conductors easily conducting the electron, my dear? Easily conduct the heat and electricity because of this free electron. Because of the free electron. Because all atoms are closely packed. So when you just vibrate one atoms, it will vibrate the neighboring, and the neighboring will vibrate the another neighboring. So immediately it will conduct the heat energy and electricity, whatever it may be. So all metals in the periodic table comes under the category of conductors. Now, second one is insulators, and these insulators, it has some electron, but these electrons are not free to move. And what are the insulators? Insulators are the non-conductors. It will not conduct anything. So the good example, rubber, plastic, glass. So we in our day-to-day life, we are using all these materials for our application purpose. Am I right? So when you come for the semiconductors, all computer chips. So what is semiconductors? From the name itself, it have the meaning. Semi, partially conductor, partially insulators. So the two elements are the most important elements of the periodic table, silicon and germanium. Nowadays we are using the computer chips, many things, am I right? And these computer chips have these two materials. So these two materials are called as semiconductors. And the final one is the superconductors. My dear, the name itself, it has the meaning, superconductor. So it will conduct very superbly. That means here there will be no resistance. There will be no loss of charge, no loss of anything. If you send 100%, that side, another side, you can get the same thing. So for many application purposes, nowadays we are using the superconductors. Superconductors are the good conductors without any resistance, without any leakage of charges, leakage of electricity, because generally we use these conductors for the electricity purposes. Clear, my dear? So all these four categories is classified based on the free electrons. Understand? Clear?
Yes, doctor.
Okay. Now, everybody we knows about this thing, and here I gave the flow chart. It's very easiest information. My dear, what I'm going to do, I'm going to explain one by one. So if you take the charge, how many charges you have?
Two.
Positive and
What are
negative.
they? Positive and negative. Very good. Now, here, when the object will be charged, when the object will be neutral. For example, if you take any material if you take any material, initially that material is the neutral object. What is the meaning for neutral? For example, if you take any object, it has same number of positive charge, same number of negative charge. Clear?
Yes.
So if any object
Clear.
have the same number of positive, same number of negative, you have to say this object is the neutral object. Clear? So that's what I put it here. The charges are unequal. What is the meaning for equal? Both positive and negative are equal number. If you just see the picture, this object, in this picture, this object has 3 positive charge, 3 negative charge. So this object is called as
Neutral.
neutral object. Okay, now suppose if the two charges are different, for example, I'm taking one object and I have 3 positive charge and 2 negative charge. Now if you just want to say these things, this is not a neutral object. Am I right?
Yes.
Why? Because positive charge is more, negative charge is small. So now this is not a neutral object, this is a charged object. But what charge object? Positive charge is exceeding, so we have to say it is a positively charged object. Clear?
Yes, clear.
Okay, I take another material and which has negative charge more, positive charge less. So what type of charge this is?
Negative charge.
Negatively charged object. So if the charges are different, you have to say the object. So first of all, you have to classify the object in terms of the positive and negative. If the positive is more, you have to say positively charged. If the negative is more, you have to say negatively charged. Now, when you come for this charge object, we classified this into 2 categories: unlike charges, like charges. What is the meaning for unlike charges? For example, if you have positive and negative, that is called as unlike charges. So if the object has unlike charges, it has the nature of attract. So if you have the like charges, positive, 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 negative, negative, what will happen? It will have the nature of nature of a ripple. Am I right? Repulsion.
Yes.
So like charges always repel each other, unlike charges always attract each other. Okay, so we finish up to this. Now this part is very, very important, my dear. Actually this part is very, very important. You can just have a look here. Now you can convert this neutral object into charge object. It's easily possible. So you can easily convert this neutral object into charge particle. My dear, you can see here I put one word called polarization. Am I right? Am I right or not?
Yes, yeah.
Okay, I told you just before, whatever the object initially you take, that object is the neutral object. Am I right? What is the meaning for neutral?
The same charge, positive and negative.
Same number of positive, same number of negative. So if you have same number of positive and same number of negative, you have to say it's a neutral object. Now, my dear, listen carefully. Suppose if you want to convert this neutral to charge, you have to either touch this object with another object. It will be easily convert. For example, I will give you one example. You take a balloon, okay? Because everybody knows about the balloon. Am I right?
Yes.
Okay, initially when you take the balloon is the neutrally charged particle, you charged object. Now what you have to do, take the balloon and rub the balloon in your hair, because our hair is a fur material. Am I right? When you take the balloon, initially the balloon is the neutrally charged object. When you take the balloon, when you rub the balloon on your head, that means a hair. What will happen? Now the balloon will charge. That means the neutral object is converted to charged object. Am I right?
Yes.
Now you can take that balloon, you can put that balloon on the wall. What will happen, my dear?
Attract.
It will stick to the wall. Am I right? Because the wall is the neutrally object. When you place this negatively charged balloon closer to that, what will happen? It will attract. Because what will happen, my dear, listen carefully. This is the wall. For example, you consider this is the wall. This wall has positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. That means the wall is the neutral object now. Am I right? Am I right?
Yes.
Yes, doctor.
So you take the balloon. Now the balloon
Yes, doctor.
has more number of negative charge. For example, after you rub the balloon in your head, what happened? The balloon becomes more number of negative charge. So we have to say the balloon is the negatively charged object now. Now, my dear, now you can see, you can take this balloon, bring close to the wall. What will happen? When you take the balloon, bring close to the wall, what will happen?
The balloon
What will
start.
happen?
Yeah.
My dear, in the wall, my dear, listen carefully. When you take the balloon, when you bring close to that wall, what will happen? The wall moves positive charge one side, negative charge another side. So it will separate the charges by automatically. So when positive charge will comes one side, negative charge goes other side, what will happen? This positive will attract this negative. Am I right? This positive will attract this
Yes.
negative. Am I right?
Yes.
Yes.
So the balloon is easily stick to the wall. So that is the nature. You can just go to your home, buy one balloon. You can just blow the air inside, rub the balloon on your head, and then please put that balloon near to the wall. It will stick. Because what is exactly going on there? The polarization phenomena is going on there. What is the meaning for polarization? Charge separation. What is the meaning for polarization?
So,
What is the meaning for polarization?
Charge division.
Charge division or charge separation, no problem, both are correct. Clear my dear? So if you want to, if you take neutral object, you can convert that neutral object to charge, and by means of the charge object, again you can make that object to polarize, to make the other object polarized. So what is the meaning for polarized? Polarized is nothing but charge division. Clear?
clear, yes.
Okay. Now, in this slide, we are just talking about the static electricity. Have you ever heard this word static electricity? Electricity, we know. What is the definition for electricity, my dear? Oh, before we go to the topic, let's say I just ask you a question. What is the definition for electricity? Give me the answer.
The change.
Give me the easiest definition, my dear. My dear, electricity is nothing but it's a flow of charge. If a charge is flowing, then you have to say electricity is there.
And
What type
it
of
has
charge?
electrons.
Yeah, that's what I said. What type of charge? Negative charge. So the flow of negative charge is nothing but electricity. But it should be takes place only in the metal. Am I right?
Yes.
But here, when you study the concept of static electricity, here the charge, the electron is moving from one insulator to another insulator. Here you are not going to take the conducting material. So you can see the information, the most important thing, the word insulator. Generally the electricity, if you want to conduct the electricity, you have to take the conducting material. But here, when you study the concept of static electricity, you can move the electron from one insulating material to another insulating material, because both are not conducting anything. Am I right? Because what is the definition for insulator? It will not conduct electricity. So in such a case, it will conduct some electron. When? By doing some experiments. You can see this chart. I have some material here. Am I right? Am I right?
Wood. Yes. Glass.
Rabbit fur, our hair, glass material, mica, wool, and all this material has the nature of
Loses electron.
loses electron. So this is the insulating material. Am I right? All these are insulator. Am I right?
Yes.
Okay.
Yes.
So what is the nature of this insulating materials? It will easily lose the electron. Okay, below this table I put another table, and here also I mentioned some material. What are they? Silk, paper, wood, amber crystal, rubber, balloon, many things I just mentioned here. What is the nature of this? It can gain electron easily, and these are also insulators. Am I right?
Yes.
Okay, my dear, you can see the picture here. You can see the picture. I take the rod. Perspex rod is nothing but a glass rod. What is the nature of the glass rod, my dear? What is the nature of the glass rod? What is the nature of the glass rod? See the picture. See this chart. What is the nature of the glass rod?
Lose electron.
Initially the glass rod is the neutral object. When you take the glass rod, when you rub with the silk material, what will happen? The glass rod immediately loses the electron. Clear? But what is the nature of the silk? When you rub the glass rod with the silk, what is the nature of the silk material? What is the nature of the silk material, my dear?
Gain electron.
It will gain the electron. So when you take the rod, when you rub the rod with the silk, all the negative charges in the rod will transfer to the silk material. Now the silk will be positively charged. The silk will be the negatively charged, because when you compare the number of charged particles, positive and negative, when after you rub the silk, what will happen? Your positive charge will be smaller in number, your negative charge will be greater in number. That's what we are saying. The silk material is a negatively charged particle after it rubs with the glass. When you rub the glass material with the silk, what will happen? Immediately the glass will lose the electron, the silk will gain the electron. So now the glass becomes the positively charged object, the silk becomes negatively charged object. But that is not a matter. But here what is exactly going on? We transfer the electron from one insulator to another insulator if we rub them together. Clear?
Clear.
Okay. Now I gave one example. What you observed from this picture. This is an example for static electricity. What you observe from this picture. Here a boy is playing the slide in the children's park. Am I right? Am I right or not? The boy is playing the slide in the children's park. My dear, listen carefully. The boy has hair on his head, and also the hair is an insulating material. Am I right? Am I right or not?
Yes.
Right.
And this plastic, the material in the children's park is a plastic. Am I right? So this plastic is the insulator, his hair is the insulator. Now why his hair is exactly standing? What is the reason? Because when the child moving from top of the slide to the bottom of the slide, he will rub his body with this plastic. When he rub, what will happen? The negative, that means initially the hair has positive, negative, equal number. Am I right? Am I right?
Neutral.
So when he just moved from top to bottom, what happened? What exactly happened? When he moved from top to bottom, what happened?
He will lose
All negative charges will stick to the plastic. Only his hair only have the
positive.
positive. When you place positive charge and positive charge closer to each other, what will happen?
Repel.
That's what his hair is standing like this. Why? Because his hair lose all the electrons. So his hair is an insulating material. It lose the electron from hair to the plastic. Now the plastic gains all the electron from his body. Now if he want to retain his hair to its original position, what will happen? He has to touch some metal. When he touch some metal, what will happen? The electron will be transferred and then it will be nullified and his hair will come to its original position. You can see I gave the explanation here. As the child moves down the slide, that means the children's playing slide, the electrons move from the child onto the plastic slide. That means when he moves from top to bottom of the slides, what will happen? The electron is moving from his hair and it will be going to the plastic. So once he removed all the electrons, only the positive charge will be left on his hair. So because of that, all hairs will be standing of the repulsion activity. Clear? Now, if the child touched any metal object, what happened? The electrons would move onto the child to neutralize, and the charge and his hair would return to its normal condition. Clear? And this is because of the static electricity. Why? Because the hair is an insulator and this children's playing slide is an insulating material, and both material have some taking some electron, giving some positive charge. Because of that, these things take place. Clear? Clear?
Clear, yes.
Yes, that's clear.
Okay. Now we come for the concept of Coulomb's law. Have you ever heard this word Coulomb's law? Actually, this is the first formula you are going to study from this chapter. First important formula. For sure, the question is from this formula or the another formula. I told you already, you have only two formulas in this chapter. My dear, exactly, Coulomb's is the name of the scientist. He predicted the electrostatic force between two charges. So what he recognized, he take two charges and the force is exactly direct relation with the magnitude of the two charges. If the magnitude is more, what happened? Your force is increasing. Am I right? Am I right or not?
Yes.
Yes.
Can I
When you
repeat?
take the product of magnitude of two charges, your force. So whatever the charge size is increasing, your force sizes will be increasing. Am I right or not? The force has the direct relation with the product of two charges, and also it has the inverse relation with the distance, square of the distance between both. My dear, see this picture. I took positive charge and positive charge, and both charges are separated with a distance r. So when the distance is more, what will happen? Whenever you increase the distance, your force will decrease. Am I right? Am I right?
Yes. Yes.
Whenever the distance becomes shorter, then the force become greater. Am I right? Am I right or not?
Yes, Doctor.
Shorter the distance, greater the force. Greater the distance, smaller the force. So both relations are very, very important. When you take the product of two charges, your magnitude of the force will be greater. Likewise, when you take the square of the distance between the two charges, if the distance is small, then the magnitude of the force will be greater. If the distance is larger, then the magnitude of the forces will be smaller. Now, if I just mix these two together, how I can write, my dear? I can write this as force is direct relation. The force has the direct relation. What happened? The force has the direct relation with charge 1 magnitude with the charge 2 magnitude, and it has the inverse relation with the square of the distance between the two charges. My dear, here r is not a radius, r is the distance. Please be careful, my dear. If you have any questions from this topic, r is not a radius, r is the distance. Clear? Now, if I want to avoid this proportionality symbol, I have to introduce one constant, and that constant is called as Coulomb's constant K. So if you replace this proportionality symbol, how you can write? I can write F, which is equal to K multiplied by magnitude of two charges. That means the magnitude of product of two charges divided by square of the distance between these two charges. Now what happened? What is the value of this K? The K is called as Coulomb's constant, which has the formula of 1 over 4 pi epsilon naught, where epsilon naught is the constant, another constant, and it has some value. When you multiply this 8.85 multiplied by 10 to the power of minus 12 with this 4 pi, you will get the value of the K as 8.99 10 to the power of 9. So generally, if K value is given, directly you can use this formula. Suppose if we give the value of epsilon naught in the exam, you have to write this formula, substitute the value. Once you substitute this value with 4 pi, again you will get the same value. This is a constant value, so don't worry. Generally, if you ask any question from this chapter, we will give the constant. So what is the formula for the Coulomb's law? The formula for the Coulomb's law is nothing but F, which is equal to K magnitude, the product of magnitude of the two charges divided by square of the distance between the two charges. Clear? Clear, my dear?
Yes, clear.
Okay, what's the time now? Time is about to finish. Am I right?
Yes.
Okay, I will stop up to this slide. Inshallah, few more slides are left. Inshallah, I will continue the rest of the topic, inshallah, on Sunday. Clear? The next coming Sunday, inshallah.
Doctor, I have a question.
Yes, my dear.
The first equation here, which come
Okay.
for by, and this I don't know what it means. By
What?
here, 1 over 4 pi.
Okay, 1 over 4 pi epsilon naught.
Yeah, how it's coming?
Okay.
It's from area.
My dear, this constant have some formula. What is the value for K? The value for K is nothing but 1 over 4 pi epsilon naught. Okay. And what is the value of epsilon naught?
What mean
What?
absolutely not?
Epsilon naught is a constant, permittivity constant. It is given here. When you're just talking something about the charges, this constant is very, very important. Clear?
Okay.
So when you substitute this value with 4 pi, what value you will get? You will get this value. Clear?
Clear, doctor.
My dear, forget about this K value. Generally, K value will be given, so don't worry.
Okay, thank you, doctor.
Yes. Yes, my dear. Any other question?
Can we leave, Doctor?
Yes, my dear, you can leave. Time is over. Inshallah, see you on next week. Assalamu alaikum.
Alaikum salam. Doctor,
Doctor.
question. We
Yes,
should
my
keep
dear.
just one formula on the right,
My
right?
dear, out of 2 formulas, we finished 1 formula. Still 1 more formula is left. Inshallah, we will see that formula on Sunday.
We save just the second formula here, not the first.
You're talking about this. Actually, my dear, this formula you can just memorize. It's enough.
It's enough, yeah. Because
But what is the value of K? But sometimes in theory question we may ask, what is the value of K? What is the
1
formula
over-
for K? Formula for K is
1/4
nothing but 1 over 4 pi epsilon naught. Okay?
Okay.
Yes, Doctor.
Thank you, doctor.
Okay. Yes, my dear.
Q is the charge or what?
Yes,
Q1 and
charge. Q1 is first one charge and Q2 is the another charge.
Okay. Thank you, Doctor.
My dear, you can, if you want to apply this Coulomb's law, listen carefully. If you want to apply this Coulomb's law, you must need 2 charges.
Yes.
And also you can
Yes.
see R. If you have 2 charges, then only you can calculate the distance between the 2 charges. Otherwise, it is not possible.
Yes.
Clear?
Clear, Doctor.
Okay, my dear. Assalamu alaikum.
We can leave now.
Alaikum salam.
Yes, my dear, I already told you, you can leave now. You can leave now, no issue. Assalamu alaikum. See you on Sunday,
Thank you,
inshallah. Assalamu alaikum.
Walaikum
Thank you
salam.
so much.